In this video, we're going to talk about regression and correlation. As we're looking at these two vocabulary words, let's start with correlation. We're going to look at two variables. And the example I'm going to use is grade for one variable versus the amount of bribe, for example. I'll do a couple of different ones, for a second variable. So I want to know if there's a relationship or a correlation. Notice how relation is part of that. If there's a relationship between the grade somebody gets and the bribe they give me. That's the first piece. The second piece is if there is a relationship, what is it? And that's the regression piece. So the second piece is what kind of relationship? What kind of relationship? Can I fit it there? Yes, what kind of relationship is the regression? So as I'm looking at different kinds of regressions, I can plot points. I'm just going to do this just really generally to start. And maybe my data kind of does something like this. So I'm starting out slowly and then increasing. This is called an exponential regression. So my points look like an exponential curve. I could have something that does, this is what temperature does. So temperature, I'm looking at temperatures, if this is 0 here, or let's say this is 32 degrees or 0 if you're up in Canada. So the temperature, let's see, so we're heading into the summer right now. My average temperatures go up, and then they go down. There's winter, then they come back up. Here's spring, and then they go back down. So this looks like, and we haven't talked about it, but if you've had some trig, more than what we've talked about, this looks like some kind of a sine or a cosine graph. So there's lots of different kinds of regressions, those type of relationships. We're going to be looking specifically at linear regressions. So for a linear regression, my data could do something like this. And I could draw, where's my ruler? I could attempt to draw a line through it like this. Nice line, actually. So there's a linear regression. I could have another linear regression that goes the opposite direction. So maybe my points are doing something more along the lines of that. So my regression is the line or curve, we're going to be looking at lines, that fits into my data. So there's a couple of things here that I want to point out now that we've got some graphs up here. So first of all, we're not going to be looking at any other kind of regression except linear regression. So what I have here are some relationships. Because I can fit a line with a positive slope, this is a positive linear correlation. On this one, I can fit my data with a line that has a negative slope. So we say that this data has a negative linear, okay, so it goes down, fits a line. Correlation is our relationship, correlation. We also have what's called a correlation coefficient. Your book has a really long calculation, and we are not going to use that. Instead, we're going to grab it off of the computer. Yay, which is way easier. So this correlation coefficient, which is R, can be described for each of these. So for a positive linear correlation, that means that R is about 1. For a negative linear correlation, that means R is about -1. We use this correlation coefficient to describe the strength of the correlation. And if I put my correlation coefficients on this continuum, I have 0 here in the middle, -1 and 1. These are my correlation coefficients R. On this end, I have a strong negative. There's my R there. So this has a strong negative correlation. And that means that my line goes like that. On the other side, I have a strong positive. So anything towards 1 is a strong positive, which means that the line that fits my data goes up. In the middle, I have no correlation. So if you think about what your data would look like for no correlation, it would just be all scattered. I couldn't fit any kind of a line to it. Just all scattered. So there's no pattern, there's no curve, there's no line, it has no correlation. Now, strong negative doesn't mean it's exactly -1. It could be -0.9 or -0.87. We use statistics. You'd have to take a statistics class to test the strength. So for now, we're just going to eyeball it. Same with strong positive. So somewhere close to 1, 0.79 or 0.98 or whatever the case may be. So for a strong positive. So we're just going to look at those in general for now. Here are some just really simple examples. I talked about grades up above. Let's plot an example of absences versus grade. So if I plotted, this is going to be a scatter plot, and I did on the y-axis a student's grade, and on the x-axis the number of days absent. I would expect, not for everybody, but I would expect that in general, a student who missed a lot of days would get a lower grade than a student who didn't miss any days. It won't be perfect, but here's a student who didn't miss any days, and maybe their grade is up here. Here's a student that missed just a couple of days. Here's a student that missed a couple days. Oh, look, they got a little higher grade, but they're a good worker. They were just sick or whatever. But I would expect a trend to happen with my data. So I would expect that the more days you miss, the lower your grade is likely to be. So if I look at that then, and I take my ruler, I could fit, it's not perfect, but I can just get an idea. We're going to let the computer give us a better idea, although that's pretty good. We end up with a negative linear correlation. Like I said, we're not going to do any of the curves. Oops, I was spelling correct. Correlation. Okay, so next, what if we plot? Let's plot hours that you study versus your grade. Okay, so I'm going to put grade again on the vertical axis, just sketching, and then hours studied on the horizontal axis. So I would expect, in general, not for everybody, but in general, the more a student studies, the higher their grade is going to be. So someone over here that studies not at all might get a low grade, or someone who studies hardly at all, they might get a good grade, or not. But I would expect to see some kind of a trend here, that those grades in general are increasing. So if I try and fit my line here, just kind of eyeballing the difference here, and you can see how this gets tricky when you've got several points that aren't perfect. And I'm just going to kind of eyeball this, but we're going to let this computer program do the math for us in a minute. That's not too bad. So here, I would expect, look how that's sort of an outlier there. I would expect this relationship to be strong positive linear correlation. So as I'm looking at these R values, I would expect this R value to be close to -1. It's not perfect, right? It's going to be a little bit off. So let's just say that this R value is, I don't know, -0.91. And for this R value, I would expect it to be close to +1. Let's say that this R value turns out to be 0.86. So a strong positive and a strong negative. How about this one? So kind of going along with the theme of different variables that might affect your grade. How about your shoe size? Shoe size versus grade. You might be hard-pressed to show a relationship between shoe size and a student's grade. I don't know, I've not conducted a study, but I would expect that the shoe size wouldn't matter. Students that have smaller shoe sizes might get high grades or low grades. Students that have bigger shoe sizes might get high grades or low grades. So I don't have a linear correlation. I don't have a curved correlation. I don't have any kind of a correlation. I would expect my R value here to be really close to 0. I don't know. I'm going to guess that it's about, how about 0.14. So something close to 0. So I'm thinking about that continuum. Strong negative here, strong positive here. I'm putting that R value at about right there. So not on the strong negative or on the strong positive side. Well, what we want to do instead of just talking about things in general is to look at some data. And I just made up some data, but we could, of course, do this with real data as well. So for my first example, I'm going to go back to that bribe versus grade. And instead of just plotting some random points into a scatter plot, I'm going to give you those values. So here is the bribe amount, which I'm going to put on the x-axis, and the student's grade, which I'm going to put on the y-axis. So let's just say, just hypothetically, that a student gave me $10 for their bribe, and they got a 65. The next student gave me $25, which is a little bit better, but not a ton. They almost passed and got a 72. The next student gave me 30. Okay, I'm expecting an upward trend, right? If I really do accept bribes. 71. So not upwards, but we're looking for a trend. Then I have a student that gave me 50, and that student scored an 85 overall. And then finally I have a student who really went for it and gave me a $100 bill. I accept cash only, and they got a 97. So if you look at that data, what would you expect? It looks like, if I'm looking for a trend, it looks like the lower the bribe, the lower the grade. Or I can say it the other way, the higher the bribe, the higher the grade. So if I were to plot these, bribe, grade, a high bribe gets me a high grade. A low bribe of $10 gets me a low-ish grade. And then in between there, I've got some other values. That one went down a little bit, that one went up, so it kind of looks like that. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Oops, I had to squish it there. And then these are my values. This is, I won't graph them all. That's 65, and then that's 100. Okay, so I just did a really quick scatter plot. This is a scatter plot. Well, what I really want to know here is if I have a strong positive correlation. It looks like I do. It looks like I could draw a positive line through this data and end up with a pretty decent trend. But in order to test that, I am not going to use the crazy formula that they give you in the book. Instead, I'm going to use a computer program. So let me switch over here to the computer. And I'm actually going to go right into our classroom. So let me switch over to the computer, and I'll show you where you can find this program. So CPU, instructor. I'm going to go into lessons, and I'm going to go into this week's lesson, which is statistics and regression. And I'm going to pick up this linear regression calculator. Look, use this for 13.6. Don't calculate by hand. That's what we want to do. Okay, here it is. So it says, use this page to draw the best fit line. Enter your x and y values, numbers only. So as I plot these, I'm going to go ahead and type my values here. And I'm going to type them so I had 10, and 10 was with the 65. Enter. And then I'm going to go 25. 25 gave a grade of 72. Enter. 30 had a grade of 71. Enter. And 50 had a grade of 85. 100 had a grade of 97. I'll hit submit data. While it's thinking, you might be asking yourself, but what do we do on an exam? On an exam, I'm going to start you with what the calculator gives you. I'm going to start you with this, and I'm going to say, what does this mean? Is this a strong positive correlation? Is it a negative correlation? You're going to have to interpret. So I will do the calculation for you using the same program. You're going to have to interpret. Okay, so let's take a look. It gave me this regression line equation. I'm going to write that down so that when I switch back over to the document camera, I'll have it. It also gave me a mean for my values. That's kind of interesting. It gave me some other things as well. But what I'm interested in are the regression line equation, which is this right here. So it gave me the regression line equation. It gave me the scatter plot, which is similar to what I had plotted, and the line that goes through it, which is this line right here. There's my slope, 0.36x. My intercept is 62.49. Okay, it's not showing me that, but it's over there, 62.49. And look at this. Use the linear regression to estimate Y. Y are your grades. X's are your bribes. So now I can type in new bribes to figure out what my bribe would be, what my grade would be, based on this formula. That line gives me a formula. What about 75? What grade would I get for a 75? Let's calculate it. I would get an 89.5. What if my bribe was $150? Now what grade would I get? Let's calculate it. 116. Well, that would give me like extra credit or something. What if I only gave a bribe of $5? Based on this formula, where does $5 land? Okay, so I'll calculate that, and I get 64. So I get a 64. But I really want that correlation coefficient. I want to know if this is close enough to 1 to say that I have a strong positive correlation. So I'm going to click on correlation coefficient. It's going to think for a minute. There it goes. Please wait. There's the correlation coefficient. Nice. So my correlation coefficient is about 0.978. I would say that's pretty clearly a strong, positive, linear correlation. Let's do one more. I'm going to switch back over to the document camera, though. So let me switch back over to the document camera. Let me do this so I can see too. Okay, so I'm going to switch back over to the document camera, and I'm going to write down what we came up with from that program. I didn't write all the decimal places, but this is the linear regression equation that we got at first. There are a bunch of decimals right here. But I went ahead and just wrote it this way, 62.5 plus 0.36x. What we did was we estimated, what did we do? We did a bribe of $75, which really what the computer's doing is it's putting the 75 in for x. Remember, bribes were x's. We want to calculate what the grade was. So the grade, which is y, is going to be y equals 62.5 plus 0.36 times x times 75. So I can also confirm what the computer gave me, 62.5 plus 0.36 times 75. 89.5, which is exactly what I got. So y, which is my grade, is about 89.5. That's not bad for a $75 bribe. Okay, so this is the equation of the line. If you're thinking y equals mx plus b from your algebra days, this is it. This is mx, though. This is b. It's just written backwards. And then there's your y equals, so it's all there. Let's look at one more example. For the last example, again, I just made up this data. We are going to compare years in school with hours that you watch TV, hours watching TV. And here's my data. 1, 2, 3, 4, 5. This is college and beyond. And then hours watching TV. So a freshman watches 12 hours a week per week. A sophomore watches 8 hours. What would that be? A junior is 5 hours. A senior is 3 hours. And then this graduate student here, or the student who didn't finish in 4 years and is on his 5th year, really wants to finish, so they're down to 2 hours. So as I take a look at my relationship here, a low years in school, in college, gives me a high hours per week watching TV. A higher number of years in college gives me a lower hours watching TV. So I would expect, let's see, 5 is only at 2. 1 is way up here at 12. So I would expect this downward trend. I'm going to let the computer do the work for me, though. So I'm going to switch back over, and I'm going to bring up that computer program. Okay, there it is. And let's see, I want to go back to linear regression. And let's go back to, I think there's a reset. Oh, here. So let's just resubmit the data. So I'm going to go back to my data here. I'm going to clear it. Then I'm just going to resubmit my data. So 1, 12, enter. 2, 8, enter, 3, 5, enter, 4, 3, enter, and 5, 2. Submit data. Look, let me arrow up here. There it is. Okay, there's my graph. Take a look at that negative correlation. It's pretty good. Here's the equation of the line. Interesting, it didn't give me many decimal places this time. But y equals 13.5 minus 2.5x. So there's the equation of the line. I could predict, using this little calculation down here, how many, let's see, x is the years in college, and y is the number of hours watching TV. What if you're in your 6th year? So in your 6th year of college, let's calculate the hours of TV per week. Now you're down to negative 1.5. Well, you can't give away hours of TV. I'd say that's a good 0. What if you're halfway through 2.5? What would that be, halfway through your sophomore year? Let's calculate that one. That would be at 7.25. So they're just finding equations, or finding values on the line. But what we really want is to see if that is a strong negative linear correlation. So let's see if we can find, there it is, correlation coefficient. It's going to take just a minute to calculate that. Oh, it was really fast. Negative 0.97. So that is a strong negative linear correlation. So I've got a strong negative linear correlation. There's that formula. Isn't that ugly? So we're not going to do that. I will do these calculations for you on the exam. Your job is going to be to interpret all of this. Let's go back to the scatter plot. I'm going to write down that equation before I lose it. Let's see, where was it? I might have to resubmit my data. Yeah, let's resubmit the data so that it comes up with the equation. Oh, did it not do it? Let's see. And we want the linear regression. Okay, there it is. So y equals 13.5 minus 2.5x. Let's go back to the document camera so that we can test this. And what I want to do is to put this, so this equation, let's see, so y is hours of TV per week equals 13.5 minus 2.5x. That was years in school. Okay, so hours of TV, remember this right here is this is my linear regression equation. So my linear regression equation, which had a nice correlation coefficient, so it was about negative 0.97, strong negative. If I use my regression equation to do an estimation, hours of TV for 6th year in college is going to be 13.5 minus 2.5 times 6. So I'm just going to verify what the computer gave me. 13.5 minus 2.5 times 6. And there it is. We got, we got equals negative 1.5, which we're going to call 0 because you can't watch negative 1.5 hours of TV. So that's linear regression. So as you're working these problems, use the regression calculator on the computer. You don't need to do anything fancy by hand. Even if Math Excel is asking you to do that, do it this way. On the exam, I will give you these numbers right off of that same computer program. Your job is to interpret. Can you do an estimation? Can you identify the regression equation? Can you tell me, based on the scatter plot or based on the correlation coefficient, if it's a strong negative or a strong positive linear correlation?